Over the last couple of years, as I've worked on these different hobby electronics projects, I've been using EasyEDA standard for my schematic design and my PCB design. More recently, I've switched over to the professional edition of EasyEDA. And in this video, I'm just going to do a little walkthrough. I'm going to build a little utility or a dev board, a type of PC that's going to let me test out a specific chip that I'm hoping to learn more about. And so I'm going to start out here and jump into EasyEDA Pro. And over here I can see in my workspace I kind of have a hierarchy that I'm organizing things, and maybe I've got some projects that I've done for microcontrollers or FPGA or whatever it might be. I might have different projects that I've worked on. For now, I'm just going to create a project at this highest level, this Pro level. I guess I could go one higher level, but within this Pro folder, I want to right click on it and create a new project. And I'll have to give it a name. And for the name, I'm going to actually jump over to showing you the specific chip that I want to learn more about. And I want to build a little test board, a little dev board around this chip. This is a CPLD. It's in a BGA package, and it's not a real big BGA, but for the purpose of this video, this I think will serve me well. So this is a 48 ball BGA, and I want to create a little board that maybe takes the I/O pins or balls and takes them out to a pin header. I want a header that lets me program the CPLD. Of course, I've got to worry about power, all that type of stuff. So that's what I want to get into a little dev board. So I'm going to go ahead and just grab this as part of the name, and I'll call it dev board and CPLD. So that's what I'm going to call this project, and I'll hit save. And it's going to ask if I want to open it, and I'm going to go ahead and say yes. And when it comes up in the upper left, you're going to see that I can go into a schematic or into the PCB. For me, I'm going to jump into the schematic and start building that out. Now, when I'm building out the schematic, there is this common library, so things like resistors, capacitors, LEDs, other really basic components. And I'll use those in this project, but I need to find a component that I can use in the schematic that represents this BGA package of this CPLD. This button right here lets me go pull up a list of components that I could use. And you're going to see different components show up. There's going to be a system. These are things provided by EasyEDA/LCSC. I might have things within my project. I might have some a personal library of components that I've created. Maybe I've marked some as favorites. But in this case, I want to be able to go out and say, well, let's go see what there is for this, XC9572XL. And I do a quick search, and I can see there are 27 different things that match, components that match that come from system. In other words, from EasyEDA LCSC. There's 16 that are coming from the public. So someone out there built something and is contributing it to this library. I would be cautious with those. I'm not saying that they're all going to have problems, but they're all far from perfect. They're not all perfect, maybe is a better way to say that. So if you are going to use a public component, just be careful and double check everything as far as the correct pinout, the right layout when you do get it onto your PCB, etc. I have higher confidence in the ones that are marked in the system category. So if I come in here, I can see there are some that I could work with. Now in my case, I could come back here and say I'm looking for this very specific part and just see if that very specific part shows up in here. So I'll do a search for that, and it doesn't. And so I might just back off of it a little bit and just grab this much of it, and I can see that narrowed it down to about 9. If I grab the next character, 7C, that cut it down to, it looks like 1. Now, if I look at that, though, and I compare it to the one I have, the part number here, 7CS48I, the one that's in the library here is a 7CSG48I. Well, the G just simply indicates that it's lead free. So, okay, that's fine. That works for me. And then I can choose place. And then I can put this out just by clicking, and then I'll hit escape. But I now have that component in my schematic so far. Now I can look at this component and just double check. If I might go to the data sheet and compare on the data sheet, do all these pin numbers as far as the location within the BGA, are those the appropriate locations? Does everything match up to the data sheet? And I'm going to assume for now, this is again a danger area, don't assume anything, but I'm going to go ahead and move forward with the assumption that these are valid. And later I'll want to just validate the design as I get closer to ordering something. Now, the sooner you can validate it, the better, of course. Or you could create this from scratch, and I'll show you kind of what that looks like here in a bit. Now, as I look at this, I will want to jump over to the data sheet, so I can pull up the data sheet and I can read about this. I can read about voltages. It will get into all the different pins so that I could see that if I'm going to use this package, which is a CS48 package, I can kind of go through and see what are the different pins. There's a D7, a D4, and I can work through, okay, that's in, they're calling it function block 1, 2, 3, 4. So there's 4 function blocks, and I can see which pins show up actually in this column right here from that BGA within those 4 function blocks. And then they'll go through and they'll describe, maybe I've got some global clock lines coming in. Maybe there's some power connections. Maybe there's just some good old GPIO that I want to work with. All of that I should be able to understand from the data sheet. And I can read through this. This is a pretty short data sheet. But if I look at this, it seems like I have a whole lot of I/O pins that I can use. And that'd be input output is the way I'm going to assume these are going to work. I can either use them as inputs or as outputs. There's some up here that have some additional suffixes like GCK1. I'm going to assume that's a global clock. So there's maybe 3 lines where I can bring in a global clock that can be better distributed within the CPLD. So that's what those might be for. There's a TS. I need to go read up, well, what is a TS? What is so that'd be a GTS, a global something. And then there's also this SR. What is that? I get into TCK, TDI, TDO, TMS, and that's going to get me into probably how I'm going to actually program this device. And so I'll come back to that in a little bit. Looks like I have some power that I'm going to have to provide both for internal power of this device and also for the I/O. What I/O level? Am I going to use a 3.3 or a 2.5? And I've got some grounds. So this starts pretty simple. I can come up here and say, well, I probably need a power rail, and I'm probably going to need a 3.3 power rail. So I'm going to come in here and just drop this and double click it and give it a name. I've been naming mine 3V3. So that tells me that this is a 3.3 volt power rail that I'm going to use. And I need to connect these pins to that. And there's different ways of doing that. The fastest way for me is I just hit Alt-W. That's, I want to draw a wire. And then I quickly connect these up. And I'm going to set up my I/O to also be 3.3 volt. So I'm going to do everything as 3.3 volt in this. And then I hit escape. So I now have those 3 lines connected to my 3.3 volt. Now, of course, I can come up here. I can use the toolbars for drawing the same types of things. I can go up to place, and I can do the same types of things. Like here, I can say draw a wire, or there's the shortcut I mentioned, Alt-W. As I go through this, the things I use a lot, you're going to see I'm just going to do keyboard shortcuts. And I'll try my best to call those out as I go through this. Seems like next I probably should put in a ground. There are some different types of grounds up here. So this is just plain old ground. Then they have a P ground. I think there's an analog ground. I'm just going to use this regular ground and place it about there. Tell it I want to draw a wire and then draw these over. And I think different people have different styles of how they would draw this. I'm just going to use the style that I've gotten comfortable with. So then the next thing I probably want to do is get these programming pins connected up. And if I come over to a page like this, it kind of shows me the same type of basically CPLD. And again, you know, I'm working with this 9572, and here they're showing an example of a 9572 and this JTAG port. So if I want to program this, I need to get a port set up that lets me connect my programmer to it to reprogram this CPLD. Well, they kind of show one example, and I think there's a series of different standards you could follow as far as how you lay this out. And I might just use this layout. So probably what I need to come in is find a header, and I can probably just search and say 1x6 pin header and see if I can find a connector real quickly that gives me what I'm looking for. Now, what I've had better luck when it comes to these pin headers is I can also go through this hierarchy here. I don't understand the rhyme or reason for the ordering. Maybe there is something logical, but it doesn't seem like it's logically ordered. But I can look for connectors, and within connectors, there is a pin headers. And when I get into pin headers, I can then see, do I catch something that meets my need, or I can fill in some of these filters up above. For example, to say that I want the pins or the number of rows or the pin structure. For example, I could say I'm looking for a 1x6. And when I click on that, I can apply the filter, and then it should narrow it down. There's some right angle, there's some straight through, etc. So I could look through that. Here's a 2.54, 1x6 straight, and I'll place that. So I choose place, and I pull it up here. Now, you're going to see me moving things around. I'm right-click dragging. If I right-click drag, I can move kind of the canvas around. If I use my mouse wheel, I can zoom in and zoom out. But I'll get it placed. I'll hit escape. I don't need to place anymore. I might want to just call this a header. And then I have to figure out, you know, let's connect these signals over here. And if I look at this, it seems like, okay, let's put 3 volt and ground as these bottom two. That's fine. So let's see, 3 volt on the very bottom. And I could probably just run that from right here. And then I need a ground, and maybe I just take that down to this ground here. And then I need TCK, which is going to be a clock, a data out, data in, and a select. So then let's get my clock hooked up. That would be here. Followed by TDO, TDI. So I'm going to get my TDO, TDI, and finally TMS. And you can choose how to wire this up. Some people don't like all the lines, and they'd rather add little labels to each of these and just put the same labels over here. You can do that with these net labels up here. So it could be that instead of me adding these 4 wires like that, if you don't like that, I can just drag across them and delete them. And then I can come add net labels, and I'll just quickly add in 4 net labels here. And if I double click, I can just say, okay, call that one TMS, TDO, TDI, and TCK. And then I can turn around and actually just, if I choose just the label, I can copy paste it and say, okay, let me actually get the rest of these lines out of here. Copy paste, Control C, Control V, and say, okay, I wanted on the bottom TCK. So let me grab TCK here. TDO, TDI, TDO, TDI, and then TMS. So this will essentially say that these are the same network, so these are going to be connected. That's another way to do this. And maybe I don't like these lines over here. I think that's kind of messy, so I might just drag over those and delete them. And it was, again, the bottom that was 3 volt. So what I might do is just grab this, copy it, and draw it over here. Copy, paste, And maybe I'll put that in right about here, and I'll draw the wire up. So maybe that's my programming port. I can drag around the whole thing, move it up out of the way. Maybe I want to document this as I go, so I could come in and say this is my JTAG port. Choose font size, color, etc. But maybe that is something I place right here. And I'll bold that. So this is my JTAG port right there. If I look through this, then I have all of these. I might want to run out to a pin header. And what I could do is just grab, maybe I'll grab 8 of them. And I've been using a little format of a pin header that's worked pretty well for me. And I might do the same thing here. I'm going to go ahead and go back to my connections, and in my pin headers, and this time I want to search for, I'll do a 2x7 maybe. So I'm going to come over and try to filter this down to a 2x7. And let's see if I can find a through hole 2.54 2x7. Okay, I'm going to use this format. And I'll just bring this over here is fine. And I'm going to just simply relabel this as header. And I think I'll use a format that looks like this. I'll put a couple of grounds out here. And then I'll go ahead and connect up the ends to ground in the middle. And that gives me this kind of format I've been using on some of my previous projects, if you've watched any of those videos. But now I have 8 pins left, and I can hook up some signals to that. I've got all these I/O pins. Maybe what I'll do is I'll run all of these first. So however many I've got here, I'm going to fill in through a bunch of these. I'm going to go to my actual document here, and I'm going to make this a larger size. I'll go with a B size, just giving myself some more room. I think I'll put this JTAG port up out of the way. Maybe I'll bring this up right here, and I'm going to need a bunch of these. So I will just copy and paste some of these so I have some to work with. However many here. Let's start with that and just see where that gets us. So I've got all these I/O pins. I can probably do this a couple of ways. I typically like to keep the pin identifier on the signal name. So I might come in here and say, okay, let's call this a G4. And so all I'm doing is picking this, add a net label, click on the pin. I can escape, double click it, and give it a name. And I can just work through all of these that way. Now it might just be faster if I just put a bunch of these on. You can drag around them and just paste. So I'm just going to fill in a bunch of these. Now when I get up to these, I may want to label these different instead of saying G7, or I might say, okay, this is G7 underscore GSR. And maybe this one I'll say, okay, this is F6 underscore GTS2. So you can choose your naming convention. These, if I just see the plain old pin name, I'm going to assume that's IO just by the name. I suppose I could have done an IO underscore G4, IO underscore, or flip that around, whatever makes sense to you. Okay, so now I've got names for all of those. Now, maybe instead of putting on the net labels like I've done, you want to just drag wires. That's fine. I find this pretty convenient myself. So what I can do now is if I know I have 8 per, I'll just come up here and control click on 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. And I'll quickly just drop those down here. So that was through E1. Okay, so there's the 4 sets I'm going to set up. And then that's going to leave me with these pins up here. So I've got 1, 2, 3, 4, 5, 6 of those that I'm going to need to set up and do something with. So maybe I will put one more of these headers in there. And actually in this case, maybe I want to hold off on those just for a minute. Let me get all of these connected. Okay, so I now have those 4 headers filled in. And that should be all of these signals all the way on the left around. And then I have my grounds. I have all my VCCs set up. I have these 4 that are going over to this here. Now, if I did want to show that these are kind of on a, I don't know, if you want to call it a bus, you can do that. So there is the option to come in here and say that you would like to place, and you can say, I want to place a bus. Now, the way the bus works in EasyEDA Pro is different than the standard edition, and it's going to assume a certain prefix in front of all of these that are a consistent naming pattern, like address 0, address 1, address 2. So in my case, it's not going to work real well to do this as a bus, and I'm just going to kind of leave this as it is. Now, one thing I sometimes will do is if these 4 are special, I'll kind of drag them out so they stick out a little bit more. And so I could do something like that. Again, this is, you know, whatever your preference is for how you want to basically visually show this. So maybe something like this works well for me. I can see that these are a little bit different. I got my 3-volt ground, all of these. I still have these to do something with. And I'm pretty sure with the CPLD, I can feed it a clock. And I've got these 3 lines that appear to be global clock lines. So I might use one of those and just bring out an oscillator. Now, in my case, I'm going to go down to my library down here. And if I go to personal library, these are just components I've built, and there's actually a little oscillator that I've already set up. This is a component I created for this oscillator that wasn't in the library from the system. So I can place it and just choose that I want to set it over here. And it's going to need VCC, and in my case, again, that's going to be my 3-volt. It's going to need an output, which is where I'm going to send the clock out to. And I think I'm going to run that clock over into this pin here. I will need a ground and then a no connect, and that's just this X that says I don't want to connect anything to that pin. Then I have left 1, 2, 3, 4, 5. You know, what are these 5 for? I'm going to have to figure those out later, but maybe for now, what I'll do is just simply set up a pin header with those things on it. And to do that, again, I'm going to go into place, and I'll take off the 2x7 filter, and I'm going to look for a 1x, did I say 5? 1, 2, 3, 4, 5. So I want a 1x5 pin header. And I'm looking for a 2.54 millimeter straight. And that looks like this one. So I'm going to go ahead and just place that here. And that's just going to be these extra clock lines. Oops. So let me copy these. And I'll just paste them on here like that. And try to catch the edge here and just pull this out a little bit. Okay, so now I will have a header that has some of these lines that I think have more meaning to it than just these standard IOs. And if I look at this, I think what I have so far should be connected up. And I can probably do a real quick check. If I come down to this DRC, I can say check DRC. And it's going to look walk through what I've done so far and tell me if I have any missing connections. So if I did have a missing connection, it would tell me, oh, this thing only has one thing connected to it, this network. And in my case, I just got a warning that, you know, one of the components has some attributes in a non-standard format. Okay, that's fine. I can ignore that. So no problems with this so far. Now I probably need some decoupling capacitors, and this other web page that I had pulled up, you know, it shows a 0.1 microfarad decoupling capacitor on basically each of the power pins. And so I can go ahead and add those real quick. So I'm going to need, let's just say one per, 1, 2, 3. I've got those three there. VCC-IO, 3 volt, VCC-IO, 3 volt. And do I have that many? So they might have a slightly different package than I'm using because they're showing more VCCs than I have, but I've got 3 of them. But if I go to the left, I can scroll through until I get to capacitors. I need to choose what size. I'm going to do surface mount, so these are surface mount capacitors. And 0603 is good for me. And now I can come out here and place some of these. Different people like to do this different ways. I normally put all my decoupling capacitors just off to the side. And so I'll put one of these in here, 0.1 microfarad. And then I will copy it. So there's the 3 to go across those. And I will put a 3 volt up here in a wire. And then I will bring in my ground. Okay, so now I have 3 decoupling capacitors that I can, on the PCB design, place as close to these pins, these power pins, as possible. Let's see, is there anything else over here that catches my eye? I don't see anything else that, you know, this simple example is showing. I'd want to search and see if I could find any other reference examples of using this. Check the, really read through the data sheet in more detail. But I'm going to just say for now, let's pretend I've done all that work and this is what I'm looking for. So let's see, I've got the main CPLD. I have a header for the JTAG port. I have a header for some of these likely special types of signals. I have all of the other IOs running to these 4 connectors that'll show up on the board. I'm going to place a little surface mount oscillator on the board that will run into this specific pin. So that all seems okay so far. 3.3 volt though, I probably am not going to feed a 3.3 volt into this. I might use a little USB connector or my benchtop power supply, but I normally start with 5 volt. So I might just add another VCC up here and label it 5V0. That'll be my 5 volt rail. And I'm going to slide all of this over a little bit. And then I'm going to bring over my 3.3 volt. And there's got to be something that's going to get me from one to the other. I will save while I'm at it here. So I might want to use a simple LDO regulator for this. And again, I can go into the parts and I can say, well, I'm looking for an AM1117 and see if I can find one of those. I was thinking maybe it's an AMS. That's probably what it is. Okay, so there's this AMS. There's a whole series of these regulators. I want a 3.3 volt, and usually those are like a -3. Okay, so here I've got a 3.3 volt, 1 amp. You know, this is a pretty basic regulator, LDO. Now, I'm sure you could do better. You could do a buck style. I'm just saying, okay, this is a way I'm going to get my 3.3 volt, and I could place this out here. And if I'm happy with this, that's great. If I don't have the component I need, or I don't like the one that you know, I'm pulling, so if I go down to library and I say project, I can look at that regulator, and let me just scroll through. So here's that regulator. Down to the lower right, I can see what it shows up like on the schematic, what it's going to show up like on my specific PCB design. I can even click a preview and see it in 3D, and so I can kind of rotate and see, well, that's what it's going to look like. So if that's good, I use that. If I don't like that though, I definitely have the option. I can go back to Start Page and say New Device, and I can make my own custom schematic symbol. I can make my own custom footprint. I can import a 3D model and make my own 3D, or my own component basically. I'm not going to do that now for the sake of time, but that's something I could do. And you will see that when I go to Personal, there are a bunch of things that I've created that I've been using. And one of those is, for example, a standoff. I might say, well, I want a 3mm standoff here. And I can now just basically bring that out. I'm going to put in 4 standoffs. And I'm going to tie those to ground. And I just created my own really simple, but I wanted to have some quick standoffs that I could just use that were exactly the size I wanted. But if I'm good with this as it is, let's see, V in is going to be my 5 volts. The V out is going to be my 3. And this V out, you got to be careful on some of these. Some of these regulators, this 4th pin, that's like the tab on the regulator, go to ground. Some don't go to anything. This one happens to be the same as the output. So pin 2 and pin 4 should be the same. So I think in this case, I can just simply go and connect this over here is probably how I'll show that. And then I'll need a ground here connected up. So something like that. So I got 5 volt coming in, then I've got my 3 volt coming out. I probably want some decoupling capacitors or capacitors of some sort, so I could come in here and say, well, let's put in, I'll pick a 0805 for the capacitor package size here, and I will put in maybe one before and one after. So I might just make myself a little more room. And between here, let's go ahead and do a 10 microfarad. I'm pretty sure I have some of those. So I'm just putting a decoupling capacitor in here. And if that's not the size you want, again, you can go in here and maybe you want to find different size capacitors. So maybe I'm going to do a tantalum and I want to find a 1206 type of size. So I could say, well, let's go find a footprint that's a 1206 and apply that and see what, okay, so you know, the actual value of this isn't so important. You can type in whatever you want. So maybe I will pick this first one right here. It's a 1206 footprint. And if I place that, I can double click it and say, well, I'm not going to do a 4.7. It's going to be a 10 microfarad. I will get rid of these two. I will rotate that, put it in place, copy it, and get it over here also. Okay, so I have a 10 microfarad on the 5 volt rail. I have a 10 microfarad on the 3.3 volt rail. And as I click this over to the right, I can see that, you know, here's the footprint it's using. And if I make that wider so you can see it, you know, it shows me that it's this length and width of 3.2 and 1.6. I suppose that's millimeter. But that would be that 1206 footprint that I had selected. Okay, so then I've got my 5 volt coming in to something. The question is, what is it going to come into? Do I want to go to a pin header, or do I want something a little bit better than that? And maybe for now, for simplicity, I'll just use a pin header. And so I'll bring 5 volt in on a pin header. I could do a barrel jack, I suppose. So that'd be something else. I could come in here and search for barrel and just see if I can find anything. I don't see anything in the system for some reason. If I go to public, you know, I can see that, okay, I've got barrel jacks. I could pick one of these. Maybe there was one. Was there one over here? So I'll pick that and bring that in here. And when I do that, I'm going to need a ground, which I think these two are going to be the same thing. And then I'm going to need up here my actual 5-volt coming in. Okay, so I've got something like that. I might want to come back down to my DRC, clear that, check it again, see if there's any new things that came up. That all looks fine. Okay, so I need, what do I need at this point? I have my decoupling caps there. I have an LDO. I'm bringing in 5 volt. I'm sending out 3.3 volt. So that all seems fine. I have a DC barrel connector, and I might also want a pin connector, just depending on what I want to, how I actually want to connect power here. So I might go back to system, and let's get back to my connectors. And so let's just say this is, that's at 2.54. So I'm just going to put a pin header up here that is my 5 volt coming in, and a ground. So this is where I can now connect to that. I'm going to label that header. I might duplicate that whole thing and give myself a 3.3 header. Something like that. Okay, so let's see here. What am I missing? I have mounts, caps, oscillator. Let's just see if this is good enough for now. So maybe I want to also add LED indicators for my power rails. And so that's easy. I can come over here and grab some LEDs. I'll do a 0603 red. And I could just simply place that even right off of these headers down here. So I'm going to put 2 LEDs for now. I'm going to move this stuff over and out of the way a little bit. Just giving myself a little more space. And then I'm going to need a resistor for each of those. So I'm going to go with an 0603. And now I can come right over here and say, okay, hook up to my 5 volt, hook up to my 3.3. Get the LED over here in a way that looks close to where I want it. 1, 2, 3. Connect some wires. And I'll just put an approximate. Let's just say that this is a 660 ohm. And this is a 1K. Something like that. So I'll hook up to the 5 volt, a resistor, bring it through the LED to ground. Same thing over here with a slightly smaller resistor, smaller voltage. We'll see if something like that would work. Okay, I will save, and then I will do one more, just DRC check, make sure that looks good. It does. So now the next thing I can do is actually flip over to the PCB and start laying that out. Normally I just hit Alt-I at this point, but I can go ahead and come up here and do an update convert schematic to PCB, which is Alt-I. So when I do an Alt-I, it will then take me into the PCB layout, and it's saying, okay, I'm going to bring in all these changes. That's all the stuff I just got done doing. And I have something that looks like this. Maybe for now, then what I want to do is get this laid out in a general format that I think makes sense. So it looks like I have, this was that DC barrel connector, if that is what this is. So I could do a quick check by looking at this in 3D and just see, does that look like the type of connector I was expecting? And I'd say, yep, that looks pretty good. This board looks really bad right now, and ooh, I can tell this is not the style of header I wanted for U2. So I've got to go fix that. So I'll close the 3D, and I'm going to go back and fix that U2. I don't know what, I obviously grabbed a type of header that I really did not want. So that's the one that's wrong. So let me go find a better That was a 1x6. Yeah, 1x6. Okay, so I just swapped that out. I did an Alt-I to update. And then I'm going to do a quick 3D view and just make sure that that pin header is... Okay, so there I've got my 6 and a 5 and these others. Okay, so now let me start laying this out in a way that makes sense. So let's assume that I'm going to take power in the upper left part of the board. It doesn't matter where I start laying all this out. But we have power there. This is my regulator. I know I'm going to have a capacitor going on the inside of this, which is the 5 volt. And that shows it, of course, on these pads. So there's my 5 volt. And I'll just start laying this out in a way that hopefully will work out. And something like this. And then I'm going to get a 3 volt out. And I'll go like that. I don't get a lot of value off of these identifiers, so I just choose those and hit delete because I don't need those right now. That's not important. And then I have a 5 volt header. So if I want to kind of see what that looks like with my scope or meter or anything like that, I've got a nice little header I can work with. And I know I'm going to go with a 4 layer on this. So I'm just going to lay it out like this, and we'll come back and maybe this can be adjusted here in a little bit. And then on my 5 volt, I want to show that I have power with a little LED, which is going to go to ground. So I might just come in here and say there is my indicator for 5 volt. And I could probably mimic all of this for the 3 volt. So let's come up here and say, here is this. And I like grounds towards the bottom, so I might just turn this around like that, which I don't think will be a problem. We can deal with that. And 3 volt down to my LED. You'll notice when I'm dragging it up, it shows the line. So if I want to try to align it with something like this other LED, I can do that. Same with the component above it. Or you can come up here and there are, if I pick multiple things, I can align, I can distribute. You've got all those shortcuts up here to use. And this one is going to go right here. Okay, so there's going to be my indicator for 5 volt, 3 volt. I have just some headers I can use with my meter or put pins in there and do something with the 5 volt or the 3 volt power. And of course on this one I can, instead of bringing in barrel, I could plug in power just using those 2 pins. Up top there's a little symbol to do text, so I might come in here and say that this is 5 volt, 5V0 ground, and I want to rotate that. Let's go like this, and I can change that font size because that is really big. So I notice I'm in mils right now. I don't like working in mils. If I just go back to my, click on my grid back here, I'm going to change that to millimeters, and now I'm going to change this down to 1 stroke width 0.15. So I start getting something that looks like that. So looking at the layer for this, I can see it's on the top layer. I need that to be on my silk screen layer. And I'm just going to mark that right there. Copy paste that. Now I can come over here and show this as my 3v3 ground. I can again, let's see, paste it. And maybe I just show that this is my 3v3 LED. And this is my 5 volt LED. Okay. Oh, then I've got this. This is the main IC I'm going to work with at BGA CPLD. And as I move this, I can see all of these are towards this side of it. Looks like pin 1 or the pin 1 of the package they're considering down here. And I'm going to put this on this side of it. I think that will be fine. And then this will be my programming port. Again, kind of dragging around, seeing which side of this does it seem like would be best. And I can be rotating this and kind of see if I get a feel for, you know, is there a better orientation that I want to try to work with on this. And it seems like this bottom side is going to be best because I got pins around here to work with. And this is probably going to be what I'm going to do right here. For now, I'm going to just pull this. Let's see, this oscillator, it looks like the output is going to come to this pin here. And so I might come over here like that. And maybe I'll get this pulled up a little bit. I'll pull this over. This seems kind of like wasted space right here. So I might just try to pull this up a little bit. And again, this is all your preference, your style, how you want to lay all of this out. Let's see, I'm going to go ahead and put this oscillator here. Oh, let's just say we've got these lines up here, something here. This could be further off to the right. Let's see where this other stuff's going to land. Programming port right there, and then see what this looks like. So it seems like that might be pretty good. And again, I'm just hitting the space bar as I'm dragging this to kind of flip it around and see which orientation makes the most sense. Okay, so this one is kind of around here. This one's across both of those. This one's down, so I might... here I'm going to go ahead and do an align bottom. And these two over here, I want to do an align left. Okay, so that's starting to look decent. Let me just pull this over here a little bit. Okay, I've got some capacitors. These would be decoupling capacitors for this CPLD. So I want to kind of see. Now these are 0603s for size, and you can see how big they look compared to this package. That just tells you that this is a pretty small package. But I've got a VCC line down here, so I might place this there. And here I have another one over here. And then there should be one more up here somewhere. So let's find that. I can hover over, let's say 333. Okay, so the other one is right up here. So that seems pretty close to where I want to place those capacitors. If I wanted them on the bottom side, I could choose them and just change it from layer top to layer bottom. So now those would be on the bottom side. I'm going to keep them on the top for now. I think that will be fine for what I'm doing here. This is simple enough, I think. Oh, and then I have some of these. Let's get these distributed around the corners. I definitely could compress this in. There's really not a lot of reason I need to have this so spread out. So I could say, well, let's bring this clock in, this oscillator in closer. And if I wanted, I could probably bring this whole thing down, or even just bring this connector down if I wanted to, just to not take up as much space. And I'll pick those and slide them over. So maybe something like that. Now I need an actual board outline. There is this right up here in the toolbar that lets me create a board outline, and you can choose the style. I'll pick a rectangular, and then I will pick roughly where I want to draw it. Now, as I'm drawing this, I can just type in numbers. So if I want to do 100 millimeter by 100 millimeter, I type 100, tab, I type 100, and it'll give me a 100 millimeter board, and you can see how big that is. I don't need anything that big, so maybe I say, well, what does 50 look like? Nope, let's go 70. And that looks pretty close. Now, of course, instead of it doing it that way, you could just drag it and draw it. And so I'm going to go ahead and draw from there to there. And there's my board outline. I like a slight rounded corner. I can right click on this and I can say add a fillet and just a very small radius. Okay, so that starts to look like that. I might save it at this point and just to do a quick 3D, to see how does this starting to look. So it's kind of looking like that. Again, I could compress this in probably much further, and maybe we'll do that for a little bit of a challenge, more of a challenge here. Now the way in which you drag around something matters. If you click from the lower right and up, anything that gets touched gets selected. If you click from the upper left and drag down, you have to fully encompass the object for it to get selected. So definitely pay attention to when you drag and drop the order in which you're doing things. But maybe this is getting close enough. I want to just grab these handles and do a little bit of resizing here, taking this down a bit more. Okay. Oops. Let's see what that looks like. Okay, so there I've got something that looks like that, and yeah, not too bad. Maybe I want to pull this down a little bit, but that should be pretty close. I can bring in power either here or here. I also have a 3 volt rail I can touch here with the meter or scope. I have an oscillator that I can provide into this CPLD, and then I have 4 output ports that are 8 I/O pins each. Okay, so that's all looking decent. I might want to do some additional silk screening while I'm at it real quick. For example, I might want to copy this and bring it over and just label what are these signals. And you can do this different ways. Maybe you want them to come out this way. Maybe you want to have it turn sideways. And an easy way to do that, I could just say that this is GCK2, shift enter, and then I would pick GCK3, GCK3. And if I want to make that font a little bit bigger, I can. The other thing, of course, you can do is just make separate labels and space them out however you want. In this case, I probably need to go with another line in between all of this and have to play with it. So that might be too much effort. If I go back this way, I could put spaces in it like this. And that's not too terribly bad. Change my height. Not that, 0.8. That's pretty close. Change the thickness. Okay, so there's some quick labels on that. These others I might not label other than something just generic that says, okay, I've got a ground, signal, signal, ground, signal, signal, ground. And I'll make that a little bit bigger. Okay, looking at that, that just kind of tells me I want to pull this down a little bit. I want to pull this down a little bit. Something like that. And then I probably want labels on this down here. So let me bring this down. And we got TMS, TDI, TDO, TCK, ground, 3V3. And then I usually put on something to identify what am I calling this board. Okay, so that's starting to look decent. Looking at the back. Okay, all good on that. So I'm going to go ahead and save this. Now I have to do all of the actual routing, getting all these wires connected. Now I'm going to have some challenges here. This is a BGA, and if I go back and look at the specs of it real quick, or the documentation for it, I'll find this information, but this is going to tell me that the pitch, this little e, the pitch between the BGA balls is a 0.8 millimeter. So not terrible. It's not a 0.5. It's not a 1.0, which I found is quite nice to work with. It's a 0.8. So it's you got to be careful about how you're going to route through this. And I don't think I could just do this on a 2-layer. Maybe you could, but I want to do this as a 4-layer just for the exercise and showing how I'm working with 4 layers. Especially if you're going to get into a slightly larger BGA, you're going to probably need 4 layers or more. Now off to the right here, I can go in and I can look at my layers, and this looks like there's a lot there initially, and maybe the easy thing to do is to go to copper and just look at the copper layers. So I can see that there's a top layer which I can hide, there's a bottom layer which I can hide, and you can just show and hide what's on these layers, or if there's something that's multi-layer, you can hide it also. As far as copper layers, all layers, I could go in and say, well, I don't want to see the rat lines, all these blue lines. I could hide those just to do my layout and get rid of that noise. Or I don't want to see something else that you see here that you can turn on and turn off. I don't want to see my top silk screen. So if I hide that, all the text disappeared, which was just a good check that I had them on the right layer. But if I click this button right up here, I can change my stack up. And I'm going to go to a 4-layer, and I'm going to have a bottom signal layer, and then I'll do an inner plane, and I'll say that that's going to be my ground plane. Then I'm going to do another plane that is my 3.3 volt. I'll call it 3V3. And then I'll have another signal layer. So 2 layers that I can run signals on, a ground plane that goes through everything, and a 3.3 plane that goes through everything. So I'll say okay to that. But now I need to go to my copper. I need to go to the 3.3 and choose that plane and tie it to the 3.3. And I can do a rebuild at this point, and it rebuilds that as a 3.3 plane. And I'll be rebuilding the copper here often as I go. But now I can go back to layer. I can say I want to be on the top layer, and I've got 4 layers set up. And I want to start doing my routing. I want to connect all these wires. Now what I do is just simply hit Alt-W, that's to draw a wire. And then when I come over here, I can click on where do I want to start drawing from. For example, I want to go from this 5 volt down to here, so I can just click on it. And it's red, which if I look over to the far right under layer, red is top layer. Now if I want to go to the bottom layer instead with this, I hit Alt-B, that's bottom layer. Or if I had other layers I wanted to go to, like a 1, 2, 3, 4, 5, I just hit those numbers. Now in my case, I've just got a top or a bottom, so it's going to be Alt top, Alt bottom that I can run this on. Something else, I can hit Shift W. So if I escape for a second, I'll just undo that. So I do an Alt W that says start drawing a wire or a track, and then I can start working my way trying to get it down to wherever it's showing me it needs to go to. So Alt W to get into wire, Shift W to change the wire size or the track size. So here I could pick a different size, like I want a nice big, in this case I picked 1.27 millimeters. So I want to go from this 5 volt, and then I can say I want it to come out a little bit, and then start drawing this however I want it to come down to that 5 volt down there. Okay, so there's a big fat trace. Once it's drawn, you can click on these portions typically and drag them and try to get it just the way you want it. So yeah, maybe I say that looks good. Or I don't quite like that I want to pull this down. I can double click on a segment, delete it, maybe delete this whole thing, go back into my wire and connect it up like that. And I say, okay, that looks good to me. Now I want to connect maybe this here. Again, if I click on this, this is a capacitor, so a 5-volt decoupling capacitor. So again, I can do my wire. I might say, well, that was too big of a wire. Or I can just say connect in from over here to over to the left. Now I notice it's blue, which means I accidentally put it on the bottom layer. I meant to do that on the top layer, so I'm just going to change it to top layer. And I want to take this 5-volt and just connect it in over there. So I've got, hopefully in the barrel, coming in with a 5-volt, and then it's going to run up to this connector, plus then I'm going to decouple it down to ground. Oh, let me get some more of this connected up, like so. These are going to be the same. This is just an LED. Okay, so then I need to get this ground over here, or I have a ground plane, so I can put a via in. And so there is a spot over here to do a via. Let's see, right there. I normally just say Alt-V. And so then here's a via. I'm going to go ahead and say, well, let's just look. It doesn't really matter where I place this because I'm going to go to the ground plane. So I might just set it right here. Now I can do a Alt-V to do a via. Shift-V lets me change the size of the via. So if I want to make it a little bit different size, that seems too big. Maybe that's the size I want to use. Place it there. And then for the via, I can choose what is the net that it's going to be on. This is going to be a ground. And then I can draw a wire between there. So now this top mount, surface mount goes to the via to get to the inner ground plane. I could copy that and paste it a couple of times over here. Do the same thing, draw a wire, maybe make it a bit thicker. And again, set these however I want to set them, but maybe something like that. Looks like I've got another ground I've got to get connected up here. Now this is a through hole, so that'll get to the inner ground plane there. Also, this is through hole, so these will get to the inner ground planes. But I'm running this 5-volt over here. These will get to ground planes. There's a 3-volt plane, so I don't really have to connect any of the through hole 3-volt stuff. But like this is a surface mount, so it needs a connection. So let's do that. This is my clock out of this oscillator. That needs to go, it looks like, to this pin here. So this is now going to start getting me into my BGA here that I'm going to have to start connecting all those symbols or signals, sorry. If I look at that, then, you know, okay, let's draw a wire, and I want to choose the size. So let's just say I pick a 0.254 and I look at that clock and, oh yeah, I can do that and get this connected over in a way that I think makes sense. So maybe something like that. And I say, okay, that looks good for that. But then let me pick one of these inners. So this one right here, I need to somehow get up. So I do a wire, and I cannot get through there. And what it's trying to do is check my DRC right now, and it's saying, nope, you don't have the right clearance for that. So I'm going to escape out of this. I might save since I haven't done that in a bit. It's, I'm sure, auto saving, but I can go to design rule. And this was a change from the standard edition to the Pro edition that gives you a lot more control and flexibility here. And so when I first pulled this up, it seemed like there was a lot there. And once you get used to it, it's not so bad. You can set up rules, and there's spacing rules, there's physics rules, like how thick tracks are, how big vias are, things like that. You can set up rules around the inner planes in my case, or copper areas, whatever it might be. But I'm going to come in here and say, okay, spacing, this is saying that from track to track, it has to be 0.102 millimeter between. Or if I'm going to go from a pad to a track, it's got to be at least 0.152, or a via to track needs to be a 0.152. So when I was trying to draw that trace through there, and it was kind of drawing a circle around the pad, it's looking at this saying, okay, you need at least this much space. And I'm going to say, no, I don't need that much space. I know I can go with a smaller tolerance on the JLC PCB and be okay. So I might set that to that. Now, you want to make sure, let's see, 0.099. You want to make sure that whoever's going to manufacture, check their actual capabilities. And in some cases, you have to pay more for some of these higher precision, like things closer together or smaller vias or whatever it might be. So just pay attention to what your actual manufacturing capability is going to be. And I'm just going to set these all to 0.099 for now. So between pads and track, via and track, I'm going to use a 0.1, but I'm just saying it has to be bigger than 0.099. And track to track has to be at least 0.099, which I'll be choosing 0.1. Now the actual track sizes, I can come down here and look at that. If I'm going to do 1 ounce copper, I'm going to say that the smallest track I can go with is again a 0.099, and the largest is a 2.54. Okay, let me just do that much and see what happens here. So now if I come in again and try to draw a wire here, I'm going to guess there's now more. This ring has shrunk, so I have a bit more space, but I still can't get through there. But this is a huge trace. So if I go to Shift W, I can go down to a 0.1, and then I can get through here hopefully fine. Not quite. If I hold down the Alt though, I should be able to get through here. It's not quite letting me. Let me check something here. If I go to my document, there's a grid. That grid is on a 0.127. That's pretty big. And an Alt snap, it's going to snap at every 0.127, and if I hold the Alt and drag or do something, I want it to go at half of that, so 0.0635, which it'll round to 0.64. So now when I come in here and I do a wire, it's kind of stuck, but if I hold the Alt, I can pick a half, kind of halfway middle, and so that's without Alt. I hold the Alt down, and now I can get through there. Okay, that looks pretty good. So now I can take this to wherever it needs to go, which, let's see, I need to go up there. So I just kind of picking my path, and when I want to kind of lock in at a certain place, I just click, and then I just keep on going. Nice thing is once you have it drawn, you can then grab the segments and just move them in a way that makes sense for you. So I'm going to just start doing this. I'm going to do a wire, and I'm doing a 0.1 millimeter for the size of that. And I just need to get all of this routed out. And then I'll just continue this process. And normally with these BGAs, now I'm not super experienced at this, but I'm slowly getting better at it. But here now, let's see, I've been taking trying to get the outer 2 rows of balls connected first. Now in this case, I run into a problem right away. It's like, okay, I've got to get that to the other side because I want to connect up to that. So I have some choices. I could do a via and drop it to the bottom. I suppose I could come up here and see, do I have room to run it around this? And I'm sure we could discuss if that's good or bad, but maybe for now I do that and say, okay, connect that there. Again, I can be tweaking these as I go, just trying to find the the setup that I think looks best. And let's just keep moving. Okay, that one. Okay, now this one, again, I've kind of got a predicament I need to get across to that. So I can either do a via, and so if I'm drawing across, I can click, and if I hit now Alt V, it'll put a via there of whatever size I used last. The other thing I can do is if I'm drawing, I can just now flip to a different layer, like hit Alt T to go to the top layer, which I'm on, or Alt B to the bottom layer, and it automatically puts a via in. If I want, I could change the via size. This is just the Shift V, maybe to something much smaller, and now go to my bottom. Let's see. Try it again. Via, Shift. Okay, so that said that's not within my DRC requirements. Too small of a via. So let's go check my design rules. And if I look at physics via size, this is what I've got set up for via capability right now. So that's pretty big minimum, 0.5. I'm going to take that down to 0.4. I believe with JLC PCB I can go down to 0.3, 0.4 without any additional fees. If you get these too small, you'll have to pay additional fees possibly if you have a really small via, but let me just go with this size. Bottom, oops, wire, top, via, okay, via 450, yeah, that's fine. Here's my 3.4, that's the smallest I've got it based on the DRC. So let's go now to bottom. Okay, that's a little bit smaller, and go like that. Maybe I don't quite like that. I might undo and do another via and change the size of the via, and I'm going to go back to this one. I like that little bit bigger ring. Now I can do a wire, flip to the bottom, and connect that up like so. So now I need to just keep flipping through these. I'm going to do Alt T to go back to my top and do a wire. Okay, that's 3 volt. I am not going to do anything here. Well, let's just do a via. Let's tap into that plane that we have underneath this. And I'll do a wire. And size-wise, 0.254. Gotta set this to be on that net of ground. No, not ground. 3v3. Let me see if I can get this, where I want it. It's not exactly. If I want to try to align this, can I do an align left? Okay. And there it gives me my 3 volt. See, I've got another one right here. I might as well just copy this over, and I'll place it right here. And I might as well connect into that capacitor. And then I've got one more right here. And I'll do the same thing. So something like that. Okay, so far so good. Let's see, these caps, I might as well put in the a couple of connections for getting me into my ground plane. So I could just set one of these off to the side. Okay, so those caps should be good there. And let me just keep running some of these out. So wire size 0.1. So one more ground over here. So I have some choices here. I can either try to run, a little ground signal out here so that I can get space for one of these vias, or I can go with a smaller via. I think the other thing I can do is I can just put a via right on it, and I'm good to go there then. So that basically is going to put the via right in pad. Now I could do the same thing over here, of course, if I wanted to, but I'm going to do that with a VIA pad. I'll run these two out. Now, one of the things that as I'm getting into this, I'm really not liking how these signals are going every which way. So I'm gonna correct that. I'm gonna clear this up a little bit. I think what I'm gonna do is save this, and I'm gonna erase all of the traces I put together over here. And there's a nice little feature over here called filter. And I'm going to tell it that I'm going to take out everything from being visible and selectable. And I can come in here and say, well, if I can see everything and hide everything, I can do the opposite and say, well, show me all of the vias and make them selectable and tracks. Now I can say, show me the board outline. You know, I could say, show me everything. But right now, the only thing that is selectable are the things that I have checked here, which is tracks and vias. So then I'm going to come in here and just kind of take a swath around that. I don't want to grab those. So maybe I'll go like this. And then I've got some down here I need to get rid of. And some, I'm just dragging over this and selecting these. Okay, that should be good. So now I can go back to my filter, make everything visible again. I'm gonna put my clock back because I deleted that part of it. Okay, so I'm gonna save this and I'm gonna jump back over to the schematic. And maybe what I'm going to change is the way I laid this out. I would like to have these by port. In other words, this is, I've got G, E, F, G, A, B, C. I need to figure out where those are at on the actual package. And this might be one way I could look at it, is I've got E5, F5, G5. Okay, these are all 5s, these are all 6s, these are all 7s. And these are A, B, C. So that's pretty simple. A through G. And then I have 7 down to 1. So 1 through 7, A through G. That's how these are being identified. And probably what I want to do is try to divide this up into quadrants. And so I think if I went back, one of these that I had up earlier kind of showed that FB 1, 2, 3, 3, 4, 1, 2, 3, 4. They were trying to break this up maybe by where these pins are quadrant wise. So let me do that. If I come in and look at this, I might want to say anything that is D or higher, 5 or higher should be clustered together. So D, maybe even 4. Let's just do 4. So D4 and higher will give me this quadrant. So let me grab D4 and higher. What I want to do now is erase just these traces right in here. And I'm going to do that like this. Okay, so now I'm going to come grab all of these again. Okay, so this is kind of that upper right cluster. If I looked at this, I'm going to say anything that is A4, so A, B, C, 4 or higher. Okay, so now as I look at this, this header I need to move down here. Let me do that. Okay, those are looking better. And actually, this would be nice to have in the upper left. So if I start working through these signals, I can kind of start to see the order, and I can rearrange these to be in an order that makes the most sense. Okay, at this point, I think I'm pretty close. Okay, it looks like I'm missing a trace here. And if I look at, can I get... I'll have to take this with a via bottom. Okay, am I missing anything? So I'm going to go ahead and do a check DRC, and let's just see what things look like. So this is showing me that, okay, I've got an issue over here. I've got a little piece of this that didn't get filled in, and so I need to do something about that. I either need to move this out, or sometimes I find on the plane, yeah, so we just need to take this and give myself a little more space. Shift B rebuilds. Okay, it looks like that got filled in. I might go one more. Okay, that looks good. Okay, so I do a rebuild. I'm going to go ahead and do a check DRC again. And that looks like that's it. So that's all I had for DRC issues. Oh, let's see. Let me get back to my top layer. So I think that is all routed and connected. Something else I typically do is I will come up here and draw a rectangle around the whole thing, and I will do a pour, top layer. Maybe I'll pick a ground for everything up here, and I'll rebuild that. But then I can draw another one, and I will do a bottom layer, ground. Okay, and I have noticed that this optimization setting, I'll have to read up on it, but if I choose that, sometimes it doesn't get things all the way filled in. I don't know what its algorithm is for dealing with this, but I'm going to go ahead and let's see, that was the bottom. Here's my top. Optimization, no. Rebuild, okay. That's all looking good. Let me come down and check my DRC. I'm going to do one more rebuild with the copper just to make sure I got it. Check DRC. Okay, DRC is good. So this is what I have so far. So if I jump over to 3D view, this is how that's coming together. So I've got power coming in here or here. Get my drop down to 3.3 volt. I have an oscillator here, which I'm sure I can move it closer if I want to, but I think it's fine where it's at. I have these 4 headers, and then I have these other 2 headers, one for programming and one for some of these other special IOs. If I look at the back side, that's what we're looking at. So all filled in with ground. Top, you can see where it's mostly filled in with ground. There's some here that didn't fill in with ground. So you can see the top is mostly filled in with ground. These areas is where it didn't fill in with ground, which is fine. That doesn't matter. I've got an inner ground layer and an inner 3v3. That's all looking pretty good. So at this point, maybe other things I could do real quick. Let me get this saved. Could go take a look at the 2D view of it just to see if there's anything that is caught as we look at that. I might change, I see that text is oriented differently. I might change that real quick. This all looks fine. You know, if I look at it in this view, you can see where I did via and pad. So I just did via and pad for these capacitors. You can see which of the BGA balls I did a via and pad. In other words, I'm dropping to the bottom side. Anytime you see these to go to my connection. So some are dropping down, going out the bottom. Some are going out the top. I can change this to the bottom side if I want to see what that looks like. And there I can see those specific ones that I dropped through on the vias. So I want to real quick, I want to go back to this. And I think that all looks reasonable. Let me check the bottom side one more time. Fine with that. Let me go back to a 3D. And that's probably good enough. I don't have a 3D actual, piece to this custom component I did. This is a little oscillator, and I didn't have a 3D model to go with that. So that's why in the 3D you're not seeing anything there. That doesn't hurt anything though. So I think that's about it. I've got this little PCB. Next thing I'd want to do is actually go check out ordering it. So I'm going to close the 3D and the 2D view. On this view, I'll just go back to the top layer. And then I can go up to order and say order PCB. And yes, I can check DRC just to make sure I didn't miss anything. That all looks good. I hit confirm. So when this order page comes up, I'll need to check a couple of options. It should detect automatically that it's a 4-layer board. It should put in the dimensions, which it came up with this 66 by 40 millimeter. Quantity 5 is the lowest number that you can order. I can come down here and pick a color. I noticed that JLC PCB is charging quite a bit for color now, so I'll stick with the no charge green. It's also the fastest option. Being that I'm using a BGA, I should pick this in NIG for a flatter finish for better soldering results with the BGA. I am going to have to choose epoxy filled and capped since I did via in pad. And if I chose a smaller minimum hole size than what I did, which was the 3 and I was using 0.45. You can go down to 0.3 for inner, 0.4 millimeter for outer diameter on your vias, and there's no additional fee. But if you go any smaller than that, then you'll have to start paying basically additional fees. And I think the rest of this should be good. So looking at the cost, then it's essentially a price of $39 US for 5 boards plus very little shipping cost if I go with the slowest option. So about $8 per board is what it ended up at. So just a real quick update. After completing the video up to this point, I did go back and looked at this, basically this pinout. CS48 is the package I'm using. And this documentation breaks it out by 4 function blocks. And I reorganized my pinout headers based on these function blocks. And basically everything that you see here from D7 down to C5, I put into one pin header if it would fit. And then I did the same thing for all the others. And where it didn't fit, I had to roll over to a nearby header. But I'm trying to keep all of the I/O pins in a header going to the same function block. And so here's the result of that. As I get in, and maybe I'll take away just the fill for a second, you can kind of see how this ended up turning out. So I've got this header here, and pretty much, its signals, all of them are these reds with one blue one, this one right here. And I probably, if I wanted to, could maybe rework it and get those all on the top layer, but this one on the bottom layer is fine. So there's a VIA in pad, and it's coming straight over here. So the rest of these are on the top side. And then you can see down here how those signals came up, and then the same for these. But basically that looks pretty decent, I think. I'm not going to complain about this setup right here. So good enough, but that is organized as far as these headers are concerned by function block the best I could. So I have them organized like so. So that's it for this video. If you've got any questions on anything I did in this video or suggestions for others as they're going through using EasyEDA Pro for this type of PCB build, drop a comment below, and thanks for watching.